We're looking at a problem in front of us that deals with functions and application. So let's read through the problem. If a basketball player shoots a foul shot, releasing the ball at 45-degree angle from a position 6 feet above the floor, then the path of the ball can be modeled by the quadratic function h of x is equal to 44x squared all over v squared. It's a negative in front of that if I didn't state that, plus x plus 6, where h is the height of the ball above the floor, x, this is the forward distance of the ball in front of the foul line, and v is the initial velocity with which the ball is shot in feet per second. So let's suppose that the player shoots a ball with an initial velocity of 29 feet per second. We want to answer the following questions. And then the first question that we have here is, let's determine the height of the ball after it has traveled 6 feet in front of the foul line. Okay, so let's go back and let's nitpick this problem and let's pull out what we know and what we're given and what variables represent what. So we're looking at, again, a basketball player that shoots a foul shot, releasing a ball at 45-degree angle from a position of 6 feet above the floor. H is the height of the ball above the floor. And so this 6 feet above the floor, I know that h is equal to 6. X is the forward distance of the ball in front of the foul line. Well, over here in this problem, it said that he's traveled 6 feet in front of the foul line. So in this case, I know that x is equal to 6. And v is the initial velocity at which the ball is shot in feet per second. Suppose the player shoots a ball with initial velocity. So our v value, our initial velocity, is 29 feet per second. So we want to determine the height of the ball after it's traveled 6 feet in front of the foul line. So when going through here, I picked a piece of information that was not relevant. The 6 feet above the floor, that was the height of the ball when they were releasing the ball at a 45-degree angle. What we're trying to find here is the height of the ball when we are 6 feet in front of the foul line. That's x is equal to 6. And the initial velocity is 29 feet per second. And so we're going to want to go into our equation of h of x, and we're going to plug in our values. And h of x, this is going to give us the height of the ball above the floor, which what we're trying to find. And so here I have h of x is equal to 44, the negative in front, x, which is 6, tells me to square my x all over v squared. And in my case, this v here is 29. So 29 squared plus x, so x in this case is 6 plus 6. So we have negative 44 times 6 squared, which is 36, all over 29 squared, which is 841, plus 6 plus 6, let's just sum that, which is 12. So this is equal to negative 44 times 36, which gives us negative 1,584 divided by 841 plus 12. So I'm plugging that in the calculator and rounding it 2 decimal places as needed. This is approximately 10.12 feet. So the height of the ball after it's traveled 6 feet in front of the foul line is 10.12 feet if the initial velocity was 29 feet per second. For part B, it says determine the height of the ball after it has traveled 9 feet in front of the foul line. So only difference in this problem here is that our X value, the forward distance in front of the foul line, is 9. And so we're looking at, another way to write this is h of 9. This is equal to this negative 44 all times 9 squared all over 29 squared. That piece has not changed. Plus x here, we're plugging in 9, plus 6. So we get negative 44 all times 9 squared. Well, 9 squared is 81. All over 29 squared, which we saw was 841, plus, well, 9 plus 6 outside of that fraction is 15. So we get negative 44 times 81. Divide that result by 841, and then sum 15. And we get that as approximately 10.76 feet. Approximate, so curly equal sign means approximating. The next part of the question says, find additional points and graph the path of the basketball. Well, we have 2 points here. We have the point when we had 6, we got 10.12. And when we had 9, we had 10.76. So I actually just by reasoning, kind of know that it looks like it would be D. Just because when we're shooting a basketball, it's going to go up and then it's going to come back down. It's going to be a parabola shape. Unless maybe I was doing a granny shot and I was doing it under. It might look more like this. C. But let's look at this. I'm looking at my values of X. It looks like these are intervals of 5. So this is 5, 10, 15, 20, 25. So we saw that at 6, so that would be about here, approximate. That is a little over 510, which is correct. If I look at 9, which is a little bit before this 10, I get a point right here, which again looks like it's close to 10.76. C would not work because for my 6, this does not give me a value of 10. 5, it's possible. This A would not work. It ends up that B doesn't work. And so the answer is D. So for the next part of the question, I just brought our question back down and the next piece. So it says the center of the hoop is 10 feet above the floor and 15 feet in front of the foul line. Will the ball go through the hoop? And so in this piece, we know that our X value, the value in front of the foul line, is equal to 15. We still are given that V is 29. And so we want to plug those values in to H of X and see if we get 10. So doing that, we have negative 44 all times 15 squared all over 29 squared plus X, X is 15, so plus 15 plus 6. So let's plug that in and simplify. So we have negative 44 times 15 squared, which is 225, all over 29 squared, which was the 841, plus, and then 15 plus 6 gives us 21. So we have a negative 44 times 225. Divide that answer by 841. And then sum 21. We get that this is approximately 9.23 feet. The center hoop is 10 feet above the floor. And so the ball will not go through the hoop 15 feet in front of the foul line. For the next portion of the problem, it says, if not, with what initial velocity must the ball be shot in order for the ball to go through the hoop? Select the correct choice below and fill in the answer boxes of your choice. So we're trying to find the initial velocity with the information we're given. So we're trying to figure out what V squared is. And we know that's when X is equal to 16. And so we're going to go back in here and we want the height of the hoop is 10. So let's go plug this in. So we want the height to equal 10 so that the ball goes through the hoop is equal to negative 44 all times, we're still 15 feet in front of the foul line, quantity squared all over V squared plus 15 plus 6. So let's go through and solve this equation. So let's simplify. And so we have 10 is equal to negative 44 times 15 squared, or negative 44 times 225. This gives us negative 9,900 all over V squared plus 21. So let's isolate the term with a V in it on one side of the equation. So let's subtract 21 on both sides. And so we have 10 minus 21 is negative 11 is equal to negative 9,900 all over V squared. We can clear our fraction here by multiplying both sides by V squared. So we would get negative 11 V squared is equal to negative 9,900. Let's divide both sides by negative 11 to isolate the V squared. Doing so, we get V squared is equal to 900. So take the square root of both sides. So we get V is equal to plus or minus 900. V is equal to plus or minus 30. Well, V is the velocity per feet per second. It doesn't make sense to have a negative velocity. And so we're just going to look at the positive. So if the initial velocity must be 30 feet per second in order for the ball to go through the hoop. I hope this video was helpful for you.